Hello, so welcome back to our channel, and in this module we are going to talk about a very common problem that occurs in the class B amplifier design. So this is called as crossover distortion. So in our previous modules, we understood what is class A amplifier, how it works, its operating principles, its advantages and its disadvantages. Similarly, we also understood what is class B amplifier, how it works, its construction, its advantages and its disadvantages. And one of the drawback of the class B amplifier is called as crossover distortion that we are going to take a look at now. So what happens here on the x-axis, you have the output voltage waveform, and in the y-axis you have an input waveform. So you have this red signal as an input and you have a blue signal as an output, and ideally this line should be linear in all these two quadrants. However, we are seeing there is some distortion here. It's not exactly the way we want. In other words, what we want, you want an amplified version of this red signal in a faithful amplified form. However, we see that there is little bit kink here and there is little bit kink here, or you can say that there is no, the output is not a faithful reproduction of the input in an amplified form. So why this happens and how that problem can be elevated is the topic of today's module. So usually what happens is that when you are at the zero input, you don't have any input, obviously the output is zero. You see the red line starts from here and the blue line also starts from the middle. So no input, no output. And you are applying that input to the class B amplifier right here. So for example, I am showing the output stage of the class B amplifier where you have used the two complementary transistor. This is an NPN and this is a PNP transistor, right? And we see that. So assuming our transistors are ideal, we see that when we apply a signal to be amplified at the input, for the positive half cycle, this transistor conducts a current and delivers a current to the load. During the negative half cycle, this transistor conducts a current and delivers current to the load, and you have ideally a faithful amplified form of the input at the output across the load, that is our load voltage. However, we are using a practical transistors which have a forward voltage drop of 0.7 volt, and here is minus 0.7 volt, in fact 0.7 volt for each, taking the absolute mod of it. So when your input is zero, you obviously your upper transistor is not conducting. It takes 0.7 volt to at the input to make it put it into the conduction mode. So the transistor conducts ideally no current or very little current when the input voltage is below zero point 0.7 volt. So you see that therefore you have this distortion here at the starting point right here. When your input is above zero point 0.7 volts, your transistor starts conducting, and again, in that case, your bottom transistor obviously is reverse bias, so it is cut off. And when the negative half cycle is coming, unless your input signal is again less than the minus zero point 0.7 volt of this transistor, you have this transistor is still conducting ideally no current or very little current. And at that time you see that this is at the crossover point. Both the transistors do not stop or start conducting exactly at this zero crossover point. Okay. And even if they are perfectly match pair. So that's why at this point you have this kind of distortion, and this is called as crossover distortion. So the solution to this problem, so that you should have a faithful reproduction, you should have like this kind of waveform, is that use an operational amplifier in the fashion shown. So what you do here, your output voltage is fed back as one of the input voltage of the operational amplifier, with assuming that this has a very high gain. So operational amplifier, if it has a very high gain, it will ensure that both inputs, that is positive and the negative, are at the same potential. So if the negative input is at connected to the output will connection will also come at the positive input, and accordingly your output here of the op amp will be adjusted to adjust and eliminate this crossover distortion. Okay, so hope you enjoyed this video. Stay tuned.